Like nowhere close, dude.
I said he goes.
All right.
So,
How to find the standard deviation? How can you explain what skewed is? So let's talk about a couple of these really quickly. All right. Did I put it on this paper? I did. So the graph provided represents the distribution of IQ scores, and this is actually how IQ is measured. So every year or however often they set the mean IQ score to what? What was the mean in this case? 100. How do we know 100 is my mean? Center, right? Remember, mean is a measure of center. And so the mean is 100. Now, did I talk about that symbol that I just drew in front of the 100 there?
Yes.
Okay. Which mean is that? So we read it as mu, but that is the population mean. If it was a sample mean, what do I use? X bar. Yeah. So this is a population mean. The average of all IQ scores is 100, right? So to answer where to go, somewhere, how to interpret mean and standard deviation. For a mean, quite literally, the what? What does a mean? It is a measure of center. So how do we talk about that? It starts with an A. The average or the typical, right? So you can say the average, and then all you have to interpret it is include context. What the average what? The average
IQ.
context. Thank you. The average what? IQ score. There's my context. The average IQ score is 100. Another way you could say it instead of the average is you could say the typical. Remember, the average is what we expect. It is what is typical. Okay? So you could say average or typical for the mean interpretation there. But that's it. To interpret mean, the average, the context is blank. So the average IQ score is 100. That's all you got to do there. Questions, comments, concerns? Okay. Notice you could write this on that sheet and maybe transfer it over some notes later or whatever you want, but we got to understand how to get that. Now, at this point, who remembers how we identified what the standard deviation was? It is a measure of spread, but how do we identify it?
like on the graph, right?
Yeah.
So like when it first starts to change into.
Interesting. So, Dewan, what's changing in the curve? What are we looking for?
You said what?
What's changing in the curve? What's Todd referring to there?
What it called?
The C thing.
The C thing.
The
The what?
Are we talking about concavity?
Concavity,
Oh, my
right?
fault.
So it is. So listen, it's concavity, and the concavity is concave up or concave down. Okay. So now there was a special point that we called it.
Yeah, that's what I thought you were talking about.
Yep. Okay. So notice, remember, this is concave down. Bless you to whoever sneezed. And then this is concave up. And what's that point where it changes? It is. It's an I word.
Point of inflection.
There we go. And so I really am glad I want to point this out. I see a couple of us getting out our notes. Guys, studying and learning can be built off of notes. You don't have to remember it off the top of your head right away. I literally introduced this yesterday. It's okay to get your notes out, but you got to know it by the time we have assessment. So make sure that we are noting the point of inflection. So notice I now come down. And so one standard deviation below the mean is 85. So what is my standard deviation? It's not 85.
I say 85.
See how I'm adding 15 to get to 115 and subtracting 15 to get to 85? So my standard deviation is 15. It's how far it is from the mean. Remember, at the end of the day, we talked about standard deviation is a typical amount the data, what was the term you used yesterday, Todd? Yeah. Yeah, but yeah, for deviations, it was getting away from something, right?
Yes.
Getting off track, is that what you said? That's what it was, right? So remember, our standard deviation is a typical amount of getting off track, right? So how much does our data typically get off track? 15, right? And so we use this symbol for a population standard deviation. It's the lowercase Greek letter sigma, but yes, you can just draw an O and then a little line on top. It is a Greek letter though. Just like mu is a Greek letter, for the standard deviation we use a Greek letter. Any guesses though what we would use when it's not a population? It's a standard deviation. And S would make sense, right? S for standard deviation. So when it is a sample, it's just S. And the reason we use sigma is because what does sigma start with? S, right? Sigma for standard deviation. It's wild. Any guesses why we use mu for population mean? Because it starts with an M. That's it. Mathematicians ain't original. I know we're using Greek letters, but it actually makes sense when you understand where it's coming from. But now we got to interpret it. That's the more difficult piece of this. How do we interpret it? Taj, what was the way you kind of explained standard deviation yesterday? It's the amount you what? Deviate or get off task or off track was the term you used yesterday, right? And what did we say our track is for data? The average, right? So, the way we would interpret it is the typical amount, notice the typical amount, I need to get context again. What was the context? So the typical amount the IQ scores, it's a standard deviation, so it's getting off track or differing. So the typical amount the IQ scores differ from what? Get off track from the, what's our track? The average, right? So the typical amount the IQ scores differ from the average is what? Is 15. Notice I'm putting context to it and using the definition to explain it. That's it. The definition of standard deviation is the typical amount the data differs from the average. So it's the typical amount the IQ scores, the context, differs from the average. Does that help? What was that?
I don't know.
Same. What? Or concave down here? I don't know what you're referring to though.
No, you called that one out.
Concave down like a frown, concave up like a cup. Alright, so does that answer the question about finding standard deviation? Okay, because remember, I'm not going to ask you to calculate standard deviation, it's just going to look at a normal curve and identify it. Okay, one thing I'll point out is, notice that's one standard deviation above the mean. So if I go the same distance, this 130 is 2 standard deviations above the mean. If I go one more standard deviation, I have 3 standard deviations above the mean. And so we go above and below the mean by a certain amount. Skewness. What do we mean by skewness? Just answer that question right there.
The long tail.
One of the tails is longer, right? So notice, is that graph symmetrical? No. That tail on the right-hand side is what?
Skewed right.
But it is, this tail is longer,
Yes, sir.
so it is skewed right. Okay. Unimodal just refers to the fact that there's only one peak. Skewed right is the fact that it's here. Okay. This graph would be considered what? Is that skewed or symmetrical? Skewed. Skewed which direction? Left, right? A longer tail on the left. Okay? So that definitely answers how to find the standard deviation. Can I explain what skewed is? How to find the point of inflection? Does that answer our question? Okay? Interpreting mean and standard deviation. Is that answering that question? Last question. Y'all said how to find the standard distribution. What do y'all mean by that? Was that the standard deviation, or yeah, that's what you meant, right?
That's fine.
Okay. And so what you probably did is you combined standard deviation with what's this curve called? What type of curve is this?
Concave,
No, the whole thing, bro.
oh.
The whole thing.
Distribution.
Hey, say it again.
Yeah, no.
Normal distribution, right? It's unimodal and it's symmetrical. So you'll probably just put those two words together. Those two concepts together. But keep standard deviation versus normal distribution separate. They are related, but they're not the same. Final questions before we get going with today. Oh, fantastic. How about you? Ready to play tonight? Are you play? You don't play? You're not playing. Gotcha. You ready for the game tonight? Okay.
I know, I'm gonna be on the video game.
Okay. Alright. So, hopefully that bell ringer. Excuse me. Do I need to collect backpacks so that we're not asking for candy and food?
No, sir.
What's Maddie asking you for? Alright. Don't do that. Don't.
Ooh, let me get one.
Let's focus. I need his focus.
Got you, bro.
Thank you. Okay. If you want it before or after class, you can do that. Not in the middle of class. Just creates too many problems and distractions. Alright, agenda for today. We have these tasks. We are learning our last new concept before we end our unit. It's on the empirical rule. Remember, I told you there are some concepts on the proficiency scale that you don't need, like z-scores and percentiles, things like that. We're stopping with the empirical rule. But before that, Jamie gets to do Hero Friday. And so Jamie couldn't find a better picture, I guess. So Jamie, can you tell us about your hero?
No way.
Okay, we can't see.
Little fingers up, man. That's crazy.
I got stand up. There's a music.
You don't, yeah, you these guys stand. You don't have to get up there.
Yeah.
What are you talking about? There are no inappropriate things in that picture.
What? I had worked it out before I sent it to
I know.
you. Okay, this my niece Kamaya.
My niece crazy.
That's my hero because like I don't know, I raised her. You feel me? Like I did that by myself. Not by myself, but like so like this my niece because my mama and my grandma they were college at the same time. And the thing is, Kamaya only 1 day older than me, you feel me? But yeah, that's my hero. That's my dog. That was beautiful.
And then on camera.
Okay. So, as a reminder, right, we are not doing percentiles, we are not doing z-scores. So z-scores, percentile, you can mark those out. Everything else we are doing, and the only things we have not covered yet really is finding the percent of data between two values on a normal curve, and find the probability of an event using the empirical rule. That's it. And that's what we're covering today.
So what we marking out? Z-score and what else?
Z-score and percentiles. Anything to do with z-scores and percentiles. Alright. So, remember we left off yesterday. Did every group get a value written down for this distribution piece.
Yeah.
Yeah, say again.
Where's our value back?
I got you.
You
So,
gonna get a bell roll?
You said it's so aggressive.
you waited until the last second.
I don't even do nothing.
Alright, I will say this, one person per group, go back and grab your phone, because I'm gonna need you to do this a couple more times. Hold on.
I don't give
Come on.
He's gonna get in trouble again.
Come on.
That's why you don't need.
That music. I don't got that. Tattoo like that.
Don't forget to put those capital letters in there, Jamie.
Yeah, cause Jamie, I don't know what type of conversation that's my subject.
I also have it written on the board. Okay.
Good.
So, the numbers on the empirical. That's what we're doing today. Okay. So really quickly, I want to point this out and I need y'all to notice here. So first things first, this is actually how I created that little bell ringer that we did. But I want you to notice, we talked about this yesterday, what's the mean for this normal distribution? 0. The standard deviation was 1, right? Which is why, if you look at the green here, one group did their best to get to 1 and -1. And for the groups that did the area, I'm sorry, we're going to get stand up in a minute. I'll also make the air a little bit warmer in a second. But area between -1 and 1 was how much? What was the area that y'all found in that curve? Say it a little bit louder. Yep, -1 to 1. Some of those groups had that. Which groups had that?
I do.
Which groups had from -1 to 1, guys? Or do we need to redo this?
I never got the assistance that I needed yesterday.
They had 3. So that means aces had 1. Kings had 2.
Yeah, we had 2.
Y'all had 3. 1, 2, 3.
We had
1,
3.
2, 3.
Yeah, we had 3.
That's what I'm saying.
But I never.
So, aces or jacks or 9s, what was the area that we wrote down between -1 and 1? Yeah. Anybody in this room have a prediction what the area between -1 and 1 might be? No. No.
0.7. I mean 0.6793.
0.67. 0. I said no.
Okay.
You said it right.
So I'm going to round it to 0.68. We go with that? Okay. Yes, Dewan.
I didn't quite get the I didn't get the assistance I needed yesterday.
Okay.
I needed help yesterday.
Well, we're about to do a little bit more. Hold on. So, for the groups that had the area between -2 and 2, and remember, as I'm drawing this, you're each going to need to practice drawing this normal distribution. So you're going to do this again in a minute. So you need to practice this. Remember, how to identify where 1 standard deviation is. So the point of inflection. Okay, so there's 1 roughly. So how do I get 2 standard deviations above the mean? But there's not another point of inflection. However, is that distance going to change?
No.
So I'm just going to boop,
Boop and the boop.
boop. So there's 2 and there's 3. So then same thing down here, point of inflection. And then how am I going to get so that's 1 below. How am I going to get 2 and 3 below? Boop. Boop. Good job. You gotta get the boop in there. If you don't get the boop in there, it's not gonna happen right. Okay, so what was the area in between -2 and 2? 0.945? So what would that round to? 0.95? Okay, did anyone who had 2 get something different?
No.
We had the same thing?
Yes, sir.
Okay, so then last one I believe was 3 below and 3 above. Alright, so area between
Now you know we're coming back.
-3 and 3, so again 3 below and 3 above. Alright, so mean is 0, standard deviation is 1, and then I go boop, boop. Because I gotta keep some of y'all awake and I'm struggling with some of y'all. Alright, there's -1, and then I go boop, boop. Alright, so what was in between 3 below and 3 above? 0.997, alright. I'll leave it there,
But how you know 0.9?
because some groups had that one yesterday.
I'll take it.
Alright, so here's what I need us to do at this point. We're going to redo this, but we're going to do it maybe with the IQ scores that we just had on that sheet, okay? So with the IQ scores though, alright, hey guys, hold on. What was the mean IQ score? 100. So up here where it says mean, what do we need to put? 100. And where it says standard deviation, we had to put 15. And so what I want the ACEs to do, I want the ACEs to look between 85 and 115. I want you to find the area underneath the curve. So that's going to be ACEs, it's going to be jacks, and 8s. Okay? I want between 70 and 130. That's going to be our kings, our 10s, and our this was supposed to be 9s and 8s. And then finally between 55 and 145, that's going to be our queens, 2s, and 4s. Okay, so you each have your own assignment. We are now looking at the IQ scores, and I want each of the groups to get up one. I want each of you to practice drawing a normal distribution. So each of you try to draw a normal distribution. Each of you needs to make sure you include the mean of 100 and the standard deviation of 15. And then I need you to find the area that you have between those values. Does that make sense? What's your question? Before we get up, what's your question, Adam? Okay, so listen. We are now, instead of using this normal distribution, this is known as the standard normal distribution, because a mean of 0, standard deviation of 1. We are now using the normal distribution for IQ scores. And so aces, jacks, 9s are going to look between an IQ score of 85 and an IQ score of 115 to find the area under the curve again.
All right.
So remember how we found the area under the curve like this?
Yes, sir.
Now, those groups are doing it between 85 and 115 for IQ scores. These groups are going to look between 70 and 130 and find the area under the curve. And then y'all are going to do between 55 and 145. Does that make sense? All right, so let's get up, let's practice drawing that normal distribution, and let's find that area under the curve for hours. But you remember, you want the area in between, right? Drag this. Drag that point. Drag that point over.
Sit down.
They're going right here. They're going right here.
is she talking
You just gotta be careful. First off, you gotta have the right So that's what y'all are supposed to be looking for. But your mean and standard deviation are that. Then you have to be careful and get your finger right on that dot. Yours is not.
Let me try to try.
Plain nice. You're gonna have to go grab a different.
I got it.
I mean, you get them good kids.
Hold on.
Yes,
Yeah,
this
you're gonna have to go grab
gorgeous, beautiful, superstar. Wonderful.
Or do it on my laptop.
Okay. So, but how do you want me to do it?
They don't know why I'm asking. What? All you're doing right now.
It's busting them up right away.
Look. They don't know why I'm having this. All you have to do is drag this to the values I So you can drag it to 70 and 130 and just write down the area, that curve. Alright guys, well actually everybody needs to practice drawing the normal distribution, but, hey guys, listen. Everyone needs to practice drawing the normal distribution, but once you are done getting your area and practice drawing, move to the center of the room so I know you're ready. So, the thing I'll point out is, have you noticed how many standard deviations are above and below the mean?
I know what I'm doing.
I did 1, 2, 3. So, that's an easy way to check how you're doing. Yeah. You take that this one. This side.
I get my hair done.
So, it's not that bad. So, if we get roughly 3 standard deviations, I'll be okay now. I would continue practicing it, but notice you want to try to get it roughly 3 standard deviations.
Boy, you can't even laugh.
Write down your area, identify and shape it, okay?
Yeah.
I was hot.
My shit look good to me.
Alright, so you got that. So, you all have between what, 7 and
Come on, go y'all, back this.
What's that night?
Hey guys, if you need to, some of us have iPads, if you need to, come over here and try it on my laptop and get the area. Hey, once you have it drawn, once you have it drawn and also include your mean and include your standard deviations, once you have that, if you need to look at my laptop to get the area, go for it. That's what I'm saying. It's like if it's not pulling up, just use that to get your area. Practice drawing first.
I wear a sticker or something about right.
Roughly. So now I'm going to use that each time. Okay. Now you're also going to want to do 100 So 115. We're supposed to be learning something. So do it the same way.
I got it.
So practice drawing like that. This is okay. And I know you talked about it on here, but how many deviations are sorry, how many three either side.
13 actually, but 13, 6.
And it's not necessarily early, but what I would recommend is probably a little bit like your body flexions.
That is a lot of money. Just to watch them.
And I can check that too.
What's the name?
Tail three got really close to the end of that tail. So that's just what I would practice. Use your fingers to measure it. Hold on 1 second. I find it hard to believe you have a hamster.
His name was Hammy. His name was Hammy.
For real?
Yes.
They were best friends.
Hammy's a hamster.
Anyway, moving up here, looking up here, okay? So, what I want to point out was this. Remember, when we had a mean of 0 and a standard deviation of 1, there was an area of 0.68 here. Between one standard deviation below and one standard deviation above. So I will point this out. If that's the area, what percent of that curve was in between here? What percent would that be? It's 0.68, so it would be 68%. 8%, right?
Yeah, close though.
Oh, come on, why you gonna go from 0.68 to 65?
If we were gonna say 68%, I was close enough.
You were close, but, alright, so when we had this area of 0.95 between two standard deviations below and two above, what percent would that be?
0.95.
So would the percent though be 95%?
0.95.
And then, hey guys, this is foundational that you have got to know before the next piece of our lesson. So, area between 3 standard deviations below and 3 above was 0.997, so what's the percent?
0.97.
Guys, you move the decimal how many times? So it's going to be what? 99.7%. Okay? Now, say again, sir.
Oh, now I would think about rounding. I was tripping.
Okay? Now, we look here, and when we look between 85 and 115, so I'm going to draw this curve really quickly. When we looked between 85 and 115, what percent of our data was between 85 and 115? 68%. And what was in between 70 and 130? 95% there. And what percent was between 55 and 145? 99.7. So even though we have different mean and a different standard deviation, did those percentages change? Did those percentages change?
Yeah, they be.
Did they?
No.
6. So, 68%, 68%, 95%, 95%, 99.7, 99.7. So what do we learn about this? It doesn't matter what the mean is, it doesn't matter what the standard deviation is, within, well, and I should say on a normal curve, on a normal distribution, within one standard deviation below and one standard deviation above. So within one standard deviation below and one standard deviation above the mean is what percent of the data? So within one standard deviation below
Oh,
and
68%.
one standard deviation above,
68%.
68% of the data.
Yep.
Okay? Notice it didn't matter what the mean was, it didn't matter what the standard deviation was. I could do it with a million more means and standard deviations, and I would get exactly the same thing.
Yep.
Within 2 standard deviations below
95%.
and 2 above, is 95% of the data. And so what's within 3?
99.7.
Anybody have a guess what this is called?
What?
Someone just said it's type of rule. Empirical. This is known as the empirical rule.
Yes, sir.
You can play with it in a million different normal distributions. Notice it only works with normal. So does it work with something skewed?
No.
Does it work with something that has 2 modes? No. So the empirical rule within a normal distribution, within one standard deviation below and above the mean, is 68% of the data. In between is 68%. In between 2 below and 2 above is 95%, and within 3 below to 3 above is 99.7. It does not matter what the mean or standard deviation is. Oftentimes, I'm going to finish writing this in a second, oftentimes we abbreviate this rule as 68, 95, 99.7. And I can tell you this right here, right now. Every year I teach this, I have students who look at me on the day of the test and they're like, Mr. Cooney, I don't know what the empirical rule is. Fellas, ladies, it's 3 numbers, 68, 95, 99.7. 1, 2, 3 standard deviations. You've got to know the empirical rule. We're going to play with it, we're going to use it and split it up and break it down. But I need you to remember the empirical rule. Well, we're going to use that in a second, but this is a full description of that empirical rule with these numbers. Right? So those are the numbers, but I'm describing it here. By the way, do y'all have somewhere to take notes on this stuff?
Empirical rule, see you what?
Yep. It's like I planned ahead. I knew what I wanted you to learn.
Yep.
Okay? Take what notes you need to for your future forgetful self.
Shut up. Plan that.
68, 95, 68% of the data. Within one standard deviation below and one standard deviation above the mean is 68% of the data. So remember how, and I should show this, remember how I shaded this earlier, and that's something I recommend? That shaded region right there, 68% of the data. Within 2 below and 2 above, that shaded region is 95% of the data. Within 3 below and 3 above is 99.7. By the way, what if I had shaded the entire curve? What percent would I have had? 100%. So is there a little bit past 3 below and 3 above? Yes, right? So the whole thing is 100%. The whole thing is 100%. You probably need to update our notes on the empirical rule stuff, guys. What?
She already did that.
That's why it's at you on your shoulder. But you have it on the empirical rule one like this? So there's a whole separate one just for the empirical rule.
I already know that empirical rule.
Because notice there's practices associated with it, right?
That's the section of this class.
We haven't done it yet. This is the mild, medium, and spicy practice that goes with the empirical rule. We're going to do some practice with it before you do those, though. Better know it's that test.
I'm still not doing it.
Yes.
What is you talking about? No, you talking about the questions. The questions get hard.
And I'm trying to say, hey, Amber,
You said medium, mild, and large.
hey, Amber, Yeah, you don't need friends.
What card?
What?
What card?
Use calculators? Would you rather do numbers without calculators?
Bakari. Bakari.
Card where?
Bakari.
I'm trying to kill you.
I can't see his mental head in it.
Alright, well, if you want to, move up on the board, get a little closer so you can see. Stand up. I feel like you can stand up and see over here.
Bakari.
Focus on your learning.
I'm trying to. My
Hey,
mate can't see.
He can get up and move if he needs to. Hold on one second.
He gonna tell you.
What's up?
It's gonna be real quick.
Oh, that's ain't first.
I would rather you come up and just like use this space up here to write.
For sure.
It's an alien spaceship. You trying me? Get you busy.
Well, only gave you one.
You don't think I got
I only need one, and you still need one. Kel, what's that thing on your head? What's that thing on your head? This thing.
Man, I have this on paper. I'm gonna replace your paper. This nigga.
What's going on? Piss me off. You know what's going on?
Okay, somebody try this too. I'm trying to.
Well, I feel like you drink. I'm not that type of person.
It slid off thing.
Do you have this? By the way, hey guys, really quickly, I should make this note, excuse me. If I were you, I might draw a visual on my notes. And what I mean by that is, we have these words, but could you draw a normal distribution for one standard deviation below and above?
Yes.
A normal distribution for 2 below and 2 above?
Yes.
A normal distribution for 3 below and 3 above?
Definitely.
That will help you significantly practice drawing that normal distribution and visually see what we're talking about. And I would shade it, right? And show that shaded region is 99.7% of the data.
Jones. Probably don't know it.
J. Mike, you got all the drawings done?
Oh, yeah. That is a very nice teacher. That is so neat of her. She is so polite. She is so
I
polite.
am actually going to take out work.
For what?
I am.
Wait, which one? Oh, is she by the
We are leaving him a
NMC there?
babysitter and having a date
Oh,
night.
what you talking about?
Also, his bedtime is when the game starts. Roughly. He goes to bed at 7. He's less than 2. Guys, you know, it takes longer to take your notes if you're talking because you're not focused. I need y'all to get your notes down. We need to continue in a second. We need to apply this, not just memorize it.
Tell them, I've been at JRTC all 3 years of school. I bet you tell them and tell a joke. Don't tell me don't tell me just say, is she alive? I'm just making sure.
It ain't 95 or 98.
95, 68, 95, 99.7.
Yeah, she got it first. I
Yeah, they show my hands.
Don't say no, I smoke it better than shit. I'm telling you, that's the first thing to leave is on my eyes. But when she said in the room, she gonna tell you, that boy ain't right for her.
This one right here,
Yeah, tell me what
It's
that
68 to 95 to 99.7 is the empirical. And I read it out of words.
You gotta be ready for these questions.
You gonna be.
What was your word? You said, but like, what was you trying to say?
Okay. We have got to continue. I see 2 or 3 people still diligently taking notes. Have we all written down the words and we're just doing these sketches here?
I would do those.
Addison, have you gotten all the words down? Okay, what do you still have?
I'm actually done now.
Okay, I'm gonna erase around that.
I think that makes any road without you trying to be police.
Yes. And by yes, I mean.
No, don't take it part. Yeah, he would.
Who else?
But we're trying to fix right here.
Looks like you can't write anymore.
Yeah, but you need to practice drawing, I promise. Yeah.
We're trying to fix it right
Gotta
here.
catch up.
No, I would do the pictures under the notes. The spicy has its own set of problems.
I believe in you. You motivate her, man.
Spicy problems are truly spicy. You don't have to, but I guarantee you, if you get your notes, you get set. Thanks. All right. So Brady, help us out real quick. Remind me of the 3 numbers for the empirical rule.
68, 99.7.
Sweet. John, remind me of the numbers for the empirical rule.
68, 95,
All right, Mel. All right, Kalia. Okay. Tyler, numbers for the empirical rule. I'm going to come back to you. Makari, numbers for the empirical rule.
68, 95, and 99.7.
All right, Chris, what are the numbers for the empirical rule? Tyler, what are the numbers for the empirical rule?
68,
We got to make sure we know these guys. 68, 95, 99.7. Deanna, what are they? All right. I'm sorry, Kamala, you go too. All right, we got it. So, hey, a couple of quick notes before we continue this. One thing I want to point out really fast here is this. Was it supposed to be DYU? Well, I'm trying to remember if I wanted to make a note about your demonstrating understanding or not. Oh, that's what I was going to say. Sorry. I meant to, which show this, no, I downloaded it. Hold on. Downloads. Yeah. I invested in technology. Alright. Listen, I just want y'all to notice, because I'm going to pass y'all back y'all's demonstrating understandings, the very first one we did. I'll pass back the other on Monday. But I just want y'all to see a contrast between what maybe some of you did for your notes on someone else's assessment versus what this was. This was not just putting down the answer, but it was highlighting, annotating, giving explanations for things. Like, if you can't, while we're going over this, do these kind of notations to help out a friend, what are you doing, right? Take care of each other. Help each other out. I'm going to print this out so that before Monday, so that each of you can have an example of this. But this is how we note and make annotations so that someone else can improve, so that we can improve. If you don't understand why, you're not going to be able to do it again in the future. Make sure you're learning why. Yes, Tyler.
There's a crack in the calculator.
Yes, I know there's one in calculator that has a crack in it. We are rough on the special stuff. Okay, second, listen. One of the things I want y'all to hear me on is this. I am capable. I need to, some of y'all have had me tell you, I need to go back out, I need you to tell me something better. And here's the reason why. I am capable is not, I am capable of easy things. That's not the point of this. Saying I am capable of doing work, yeah, congratulations. Like anyone can show up and do work. Are you capable of learning from it? Because that is impressive. Are you capable of talking with people about the math? Because that is hard, but you are still capable of it. Are you capable of being better today than you were yesterday? Okay? Like, that's what I need you to hear me on. We aren't telling ourselves we're capable of easy things.
Yes.
We're telling each other and telling ourselves that we are capable of hard things to be better. That's the whole point.
Yes,
Tell yourself what you're capable of as you come inside my classroom each day. Now, from there, I want to pull on some of the textbook pages. So, M5 dash, I don't know, I think it's 14 or 15, somewhere in there. We're not going to spend long on it. By the way, our phone should be back up. Sorry, I should have made that. No, we got 20 minutes left. 20 minutes up there.
it's a clothing brand.
But I need it up there. If your phone is in the pouch,
I'm trying to pass on my products. Can you stop doing this?
I think it's page 15 or so. It's whatever this 1.2 is. It'll look like this. What page is it? Oh, it's right. 14. M5-14. M5-14. Oh yeah.
Man,
So I need to do, yeah.
Come on, keep them on.
I was told you turn that into Okay. Thank you for getting your phones up. Okay, so M5-14, I just want you to remember, okay, listen, these are textbook pages. Like these pages from the book have good and useful information, so pay attention to that. Notice it literally lays out the mean with that symbol U. And it talks about the mean of a sample is X bar, the standard deviation, right? So pay attention to your textbook. This is another good resource. For my class, you're going to have tasks that we work through. You're going to have the Frere models and the check your understanding problems. You're going to have the videos that I record, but you are also going to have textbook pages. Everyone has the resources to be successful, and I will also help you beyond that, okay? Make sure you're doing what you need to do to be successful, though. All right, so we already did this. Please note, you can now do this entire normal versus non-normal. Check your understanding. Now we are working on the empirical rule that I already showed you. Just be aware, okay, this is the beginning of the task. This is the beginning of the lesson. We've already done all of these ideas. Not this exact one, but all of these ideas, because what it's trying to get us to is the percent of data within one standard deviation of the mean. Tamaya, what percent of data is within one standard deviation of the mean?
Got it.
How much? 68%.
Yes, sir.
Right? There we go. There we go. Jaquel, what percent of the data is within 2 standard deviations of the mean? Okay, tell me this. What are the 3 numbers we have to know?
68, 95, 99.
So what's within 2 standard deviations? Well, 68's 1.
95.
Oh, there we go.
Yes, sir.
68, 95, 99.7. Guys, it's laid out that way because it's 1, 2, and 3.
Hey, look at this.
This is
All right. So Bakari, what percent of the data is within 3 standard deviations? 99.7. That does not change. Okay.
efficiency.
Oh, look at that. We've already tackled all these ideas. Listen, the empirical rule, that is what we've already done through y'all. And so again, remember, I need y'all to hear me on this. Did y'all know what the empirical rule was? No, the textbook just lays it out here. But I asked you to go online and I said, hey, do this thing, and then we found a pattern out of that. We saw that repeatedly within 1 standard deviation was 68% of the data, within 2 is 95%. So sometimes I know where we're going, just trust me, do the thing, and I'll connect those ideas and I'll ask questions to get us there. One note I do want to make is this, the standard normal distribution. This okay, this, I want y'all to hear me on. Remember, we did this distribution. We had an IQ of 100, or mean 100, standard deviation of 15.
Big
Okay?
old flat.
Huh?
It was a big old flat. It was a big old flat that had blue pad.
What's draw that?
Easy.
I heard someone ask me for permission for something, and I said, okay.
No, bro, I said a big fly blue pad.
No, I didn't see that. All right, look, right here. This distribution is approximately what?
Where?
F14.
No, we're past 14 by now.
F14.
We're on to, keep going, keep going,
25.
keep going.
23.
Page 23.
Oh.
Yeah. M5-23 is where we are right now. I just expected when I changed the slides that you realize, hey, I'm going to turn the pages in my book until I find the ones that match the slides.
I did that.
Wow, I know, right?
That don't match the slide.
I did that. Yes, you do.
On the slide, they lined up.
Oh, I'm so sorry. So, this distribution is approximately what? This distribution is approximately
100%. 99.7%.
shape of it. What shape is it?
Oh,
Unimode. Unimode.
what?
It's unimodal and symmetrical, so it is
Normal.
normal. Yeah.
Stop biting each other.
Guys, listen. Eyes and ears. This is approximately normal, but there's a special type of normal curve called the standard normal. The only difference is the standard normal has a mean of 0 and a standard deviation of 1. So I can convert this to the standard normal curve, and I will ask you about the standard normal curve.
Yeah.
What would 100 be on the standard normal curve?
Always eight. You said what?
Skewed.
What would, remember, it'd be 0. It'd be what? 0, right? The mean is what? 0. 115 is going to be 1. 130.
2.
145. 85.
-1. -2. -3.
Okay, so notice I can convert any normal distribution to a standard normal by just making the mean 0 and the standard deviation 1. Okay? Alright, now we're going to use this here, and that's why I wanted to address it. So now we're on activity 2.2. So flip a couple more pages. Not quite that far. How far is it? 25, okay?
2.2.
And so, I'm going to do one of these with you, and I want y'all to see this, and we're going to work on vertical surfaces to play around with it and make sense out of it. But right here, first off, I want to point out that distribution A and distribution C are for populations, and B and D are for samples. Why do I, looking at those, know these are populations and these are samples? There's a key detail. Look at those graphs. What tells me population versus
The Latin word, the Latin letter.
the Greek? What is it? Sigma. Look how this standard deviation is. Sigma, right?
Yeah, sigma.
Sigma is for the population. S is for the sample. So population distributions versus sample distribution. Next, what percent of the data is greater than the mean? So when you're doing this, what I would do every time is I would mark it. I want the mean, okay? And then which direction would I shade for this problem? It's greater than. First things first, is it possible that you could just answer this and just write down the percent? 100%. However, would that, just that detail, show some evidence for why you got the answer you did? Remember, I want evidence for the values that you answer with. Alright, so just shading like that is going to be evidence. Now, does anybody have an idea what the percent of the data greater than the mean might be? Why don't you talk about within your groups for 60 seconds, then we'll come back. What percent of the data do you think is greater than the mean?
What percent greater than the people? The bottom. The right side back.
Alright, so let's talk about it. So, what do y'all think? What percent of the data is greater than the mean? Yes, but what percent is that? Why do you think I'm 50, J. Mike?
We split it in half.
Can we do that? Can we just say we split it in half? Say again. Hold on. Preston asked the question first. Respect it. What was your question? How would it be greater than if it's half?
It is.
So if I shade in the entire distribution, what percent of data do I have? 100%. So if I'm only shading in the greater half, what percent of the data is that? 50. So that is half of the distribution, right? And so we're going to use this idea of halves a lot within this next little bit. Okay? Does that answer your question, Preston? Okay. So, at this point, I want you as a group to go to your vertical surface and try to figure out what percent of the data is between the mean and 2 standard deviations below the mean. We're going to take 5 minutes, come back together. Alright, so you got a maximum of 5 minutes to figure this out.
No, it's not. That ain't nothing but bad news.
Oh, wait, no, not that's not right. I just said it. I just said, didn't I
Lie to him not gonna make it better.
Okay, so guys, go. I got to go.
I ain't saying that.
Go.
Kenny?
What?
Amber.
I'll have to use your test to replace this demonstrating understanding.
Oh, that's terrible.
Alright, now we need to talk.
Wait, hold on a second. We got
Oh.
Oh!
Where's Carl?
No, you trying to talk about oh, upline.
Start there. Start thinking about it. If you're trying to do this all day, it's not going to make any sense. Come back on. Check on it in a second. What's wrong? Hey guys, if you haven't drawn anything yet for B, then you're already behind the curve. We got to draw and shade to help us make sense of this. You know we're doing B, right?
What we gonna say?
Miguel, Kennedy. Y'all focused on learning right now?
So you're the same detail.
Okay, so yep, in between there. Now I would see how you mark the mean. What else could you or should you mark? What percent of the data is between the mean? You mark that and 2 standard deviations below the mean. And I want you to think about that empirical rule that we started. What could you use in the empirical rule?
Top of the five.
Think about what we do have.
Yes, because it's our last deadline. Wait out. Monday.
Put a little penny bottle. Measure a spread. Measure a spread.
So let me ask you this. Think about the empirical rule. Based on what you just shaded, which part of the empirical rule do you think you could get wrong?
Jesus bless you.
What are the 3 numbers for the empirical rule?
5% kind of.
68? So what did you mark there? What's the leftmost boundary? So why are you going to use the 68%? Maybe think about something with that. Okay, there you go. That's a decent drawing. That's a decent drawing. So -1, because that's a reflection. Take roughly that same distance. That would be -2. Take roughly that same distance. What's the problem? I don't even see the problem in hand, guys. What's that? Here's my mean, right? Here's my standard deviation. I want everything. Thank you. Thank you. I need everybody to come to the center and I need us to talk about it. Okay? Walk to the center. Walk to the center. Okay? Okay? First things first. First things first. I'm going to work over here. Okay? Boop. So, Brady, scoot over to the side. Really quickly, guys. And this is not for embarrassment, this is for learning. Right here, we've got to work on drawing our normal distribution if it's looking like this. We've got to be able to identify that point of inflection and use that same distance to get our next standard deviations. But here's what I want y'all to pay attention to. We have the mean marked, and we have -2 marked. Guys, your learning matters right here. So we're supposed to be using the empirical rule. What part of this empirical rule would make the most sense based on what we have marked? Why do you think that?
It's the smallest one.
It is, but where's this boundary at?
I'm thinking 95.
Oh, that's 95, right? Yeah. Now, that 95 was all the way to here.
Oh.
Right? 95 was from 2 below to 2 above. Okay. So how are we going to find just from 2 below to the mean?
Divide.
Divided by what?
Oh, what's called by half of.
Wait, so how much?
Oh.
Guys, remember when we did everything greater than the mean? Wasn't that half? How much is this of the 95%? Look, that's half of it, right?
Yeah.
So what is this? This is half of 95,
47.5. Oh, yeah, no.
That's all you have to do. Notice we're using the -2 so we know. Guys, hey, we've been doing well today. I need us to focus for the last 60 seconds. I'm almost done, so you can actually pack at that point. But I have people packing, so I know they can't be paying attention.
Exactly.
J Mike, I need us to make sure we understand this. Look, we're going to pick up with this, but all we're going to do is we're going to play around with the 68, the 95, and 99.7. And we're going to be taking half the stuff, right? I only have the left half, so I did half
Of the
of
left.
95%.
Yep.
And I knew it was 95% Alexis because we stopped where?
And the 95.
And they too, right? 68% is within 1, 95% is within 2, 99.7% is within 3. So if I'm using those, I now know how to use them. Have a fantastic weekend. Don't forget, you are always capable of
Ain't it 34, 47,
Hey, fuck this shit.
and
For those halves, yes. I would just remember the 68, the